Hi guys, and welcome to today's video. We're going to be covering HSRP, doing a little bit of a deep dive on it. So HSRP basically stands for Hot Standby Router Protocol, um, and it's used in a lot of networks for redundancy, mainly to edge devices, so things like your routers and switches. So I'm just going to kind of run this through with you. So what we're going to cover is what HSRP is exactly. So the description when it kind of came to be, and then we're going to look into a HSRP packet, what data that will have in there, what information, as well as its features. A little demo just to show you what we're going to configure today. And then we're going to cover version 2 as well. There is actually two versions, so there's version 1 and version 2, and what the differences are between them, as well as some HSRP commands that are useful for deploying HSRP, troubleshooting. So, you might be on a router that you're not familiar with and you need to get the information quick about how it's been set up, what its virtual IP address is, things of that nature. And then we're going to actually deploy HSRP using Cisco Packet Tracer. So, firstly, what is HSRP? So, like I said before, it's a hot standby router protocol. It was first introduced by Cisco and it allows you to achieve network redundancy on IP networks. It does this by ensuring that networks are able to recover from first hop failures in network edge devices. So, it's a first hop redundancy. So, it allows two or more routers to share an IP address and a layer 2 MAC address. They can act as a single virtual router, so it actually uses a virtual IP address and a virtual MAC address for this to work. Routers in this configuration that are members of the virtual group are known as a standby group, and they continually send messages to each other, hello messages, to make sure that they're reachable on the network, and that basically, yeah, that they're available. Um, and this allows each router to assume the role of the other. So the two main roles in HSRP is an active router, so that's your primary router, and I'll be doing all the routing responsibilities. And then you've got your standby router. So if anything happens to the active router, it will automatically know to switch over to the standby, and then the standby will take the active role, and vice versa. So yeah, like mentioned here, these roles are shared. So meaning if the active router goes down or loses connectivity, the standby router changes to the active role. Hosts still continue to send packets to the virtual IP address, and the transition is seamless and transparent. So the client devices shouldn't really notice any drop of connectivity um, because of that automatic switch over. So it's a failover basically. And even though you may have two or more routers, one thing to take into consideration when designing your topology and your network layout is that in HSRP mode, only the active router forwards the packets to the virtual IP, the virtual gateway. So you could have, this is something maybe to take into account if you've been given like some budgeting plans or anything like that. You could have the router set up in HSRP in active, and then you could, for example, have purchased two more routers that are in standby mode, but they're not actually going to get utilized all that much. They're just there for failover. So it's about weighing up the pros and cons in that design. Just depends on your scenario, basically. And this is just like a little overview of a HSRP packet, so what type of information you'd find in the packet. So as you can see here, we've got the version. So in this case, it's version 1. What state it's actually in, this router, as well as the hello time value, which is at the moment 3000 milliseconds. So that would be 3 seconds. The hold time, which is 10,000 milliseconds, so that's 10 seconds. And these are actually the defaults. You can change these in the configuration. And depending on your needs, especially in enterprise networks where it's a large network and you're very strict on your downtime, you need as minimal as possible, you need it to be as lightning quick as possible, then you would want to look into actually changing these times, probably to set to quicker times basically. But then you've also got the priority here as well. So in this case, the priority is 100 and the standby group that it's in, and in this case it's just number 1. authentication data. So this is something we're going to cover here, that you can deploy on the routers, which is giving these, basically it's like a pre-shared key between each other to authenticate, so that you don't, for example, nobody can just plug in a router, set up HSRP, and suddenly become the main virtual gateway, which you could do, if you gave it higher priority than the ones already in place. So that's where authentication is actually really important, and it does in Cisco iOS. It supports MD5 encryption as well, so definitely something to consider there. And also it lists the virtual IP address, which in this case we set up as 10.25.25.1. So yeah, that's just a brief overview of a packet there. So let's go through some of the features here. So first is just regarding the addressing. So when you configure routers to be part of the standby group, they listen for the MAC address, the virtual MAC address for that particular group, as well as their own built-in MAC address. So just as an example, HSRP uses the following virtual MAC address, which is widely recognized as its standard and is configured in the below format, um, where the end section is the actual group number. So in this case, let's say group number was 1, that would be 0000 dot and then 0C07 dot AC01. That's how it would look in hexadecimal there. The next feature, which is definitely a must to have enabled for this, for it to be able to actually switch over, is preemption. So with this feature enabled, it allows the router with the highest priority to immediately become the active router. Priority is determined by the priority value, which is set in the configuration. So yeah, during setup you can set the priority value. So you'd have the higher value would be the router you want to be active, and the lower value would be the standby router. Uh, and then it also takes this by the IP address. So each case, a higher value is priority on the network. When a higher priority router preempts a lower priority router, it sends a hello message. So, like I was talking about before, this is how it kind of checks the status of each router. So, when a low priority router receives a hello message from a higher priority router, it changes to a speak state and sends a resign message. So, that's where it's actually passing over that role. And so, the other router then takes over the routing responsibilities and becomes the active router. Hopefully, I made that sound, make sense a little bit. But yeah, that's how it basically works. So it sends that resign message, if it's a lower priority, and it sends that to the router that's going to be active, and that's how it knows to switch over. And like I mentioned before, the default for the hello message is 3 seconds, and the hold messages are 10 seconds, and these can be actually changed in the configuration. So the next thing is preempt delay. So you can actually delay when this switches over to the active router. So it allows you to set a time delay value, and this gives that router enough chance to populate its routing table before becoming the active router. So if you've got some static routes, maybe for example, that you've got in there that you need to manually put in, you can actually add a delay in order to do that configuration. I would advise them reflecting the routing tables be reflected beforehand, so you don't actually have to put the delay in. But it just depends on the actual setup. And just to show you the command here where you can configure the priority and the preemption, just using that command below. So as you can see, it'll be the standby, then it'll be the group, so it'll be group number, then the priority number, preempt delay, and how many seconds for that delay as well. The next one, which is really handy, is interface tracking. So basically, let's say, for example, you've got your active router and your standby router. Something goes wrong with the active router, it needs to switch over to router 2. Let's say this standby is router 2, this active is router 1. But how does it know if it's not got any problems on any other interfaces? So let's say this is working fine internally, but on the one interface it's down for whatever reason. How would that know? It wouldn't know it on its own. You'd have to put interface tracking in place. Basically, what that then does is it will lower, if the interface is down, it'll drop the priority by default by 10, and it does it in intervals of 10. So yeah, I'll just go through this. So it's great for redundancy using the active and standby router configuration. However, in its simplest configuration, it can only detect if the router that's about to take over the active role is reachable on the network. And that can pose an issue, yeah, like I was saying, the router may be reachable on the internal network, but unbeknown to HSRP configuration, the router's outside facing interface has a fault and is down, meaning that even though the redundancy worked internally, connectivity to external wider area network was not restored. Interface tracking provides solutions, so this is by allowing you to configure HSRP to monitor another interface um, in order to alter the HSRP priority for a given group. If the specified interface goes down, the overall priority of the router is reduced and allows another router with higher priority to become the active router. So this is how it works. Priority is really important in HSRP for this to actually work. It is based on who's got the highest priority on the network, so it knows where to switch over. When multiple interfaces are down, priority is reduced in a cumulative fashion, like I was mentioning before. So you could explicitly set this in HSRP configuration, but by default, priority value is lowered in increments of 10. And here's another example. So for example, the route has a priority of 110. An interface goes down, it now has a priority of 100. Two interfaces go down, priority is now 90, and so on. And if you do not set a standby group number when configuring, HSRP will automatically set a group number to 1 by default as well, so just take that into account. Okay, and the next feature is use burned in address. So this is where it allows HSRP groups to use the physical MAC address rather than the virtual. This does resolve some limitations in certain networks. It depends if they've got maybe MAC address filtering and other rules in place, but you wouldn't really see this now just because there are limitations. So when the router becomes active, the virtual IP address is moved to a different MAC address, so it doesn't really work well with ARP responses and also proxies. So if you've got ARP proxies in place, it can cause certain issues on the network. So just a few things to take into consideration. But yeah, you wouldn't really see this used in modern networks now. Another feature is having multiple HSRP groups. So you can have multiple standby groups, which further enables redundancy and load sharing in networks. Allows redundant routers to be more utilized. And while a router is actively forwarding packets for a standby group, it can be actively listening or in standby state for another. So you can actually have it doing this role for multiple different segments of the network. So you can actually make it a lot more efficient to have one router that's able to be a redundancy point for 5 networks on that same router. So another thing to consider. And also configurable MAC addresses, so you can provide first hop redundancy for other protocols, such as advanced peer-to-peer networking, which use the MAC address to identify the first hop for routing purposes. So in this case, it is often necessary to be able to specify the virtual MAC address that uses a standby MAC address command. And the virtual IP address is unimportant for these protocols, so it is just MAC address focused. And just the command there as well if you want to set that up. And another feature is the authentication, which I was talking about before. So it does use a shared clear text key to authenticate between HSRP enabled routers. It's contained within the HSRP packets, which we showed previously. And it also prevents the low priority router from learning the standby IP address and standby timer values from the higher priority router. So you could actually configure this with the following command below, and like I said, you can also encrypt this with MD5, which is supported in Cisco iOS. And the last one here is just IP redundancy. So it provides stateless redundancy for IP routing, which means it can only maintain its own state. So it assumes each router builds and maintains its own routing tables independent of one another. So that's another thing to take into consideration, like I said before, if you've got any static routes in the table on other routers that may conflict if they switch over. Just make sure you've got that covered. But yeah, that goes a bit more in depth, and that is more around your actual network configuration, which will differ for everyone. And yeah, I'm just going to show you now a quick video just demonstrating what we're going to configure in Packet Tracer, and then we'll continue from there. Hi guys, I'm just going to show you the HSRP demonstration here. So this is for the hot standby router protocol. We've just got a basic setup at the moment. We've got two routers, a switch, and three client PCs, as you can see. And for this demonstration, I've just popped them on the 10.25.25.0 network. And that's with a network mask of 255.255.255.0. As you know, that will give us 255 hosts, 254 that usable. And I've set these client PCs as the default gateway being 10.25.25.1. And as you can see, I've got router X1 and router X2. So router X1 is actually the active router at the moment, and that's on a .2 IP address. And I've also listed the MAC address here. So that's its actual physical address. And then the second router is on the .3 host address. And the virtual router, which HSRP creates, I've configured that to be 10.25.25.1. And as you can see, here's the virtual MAC address it actually assigns. And at the end, it also has the standby group number. And in this case, it's just 1, so 01 to represent that. And I'm just going to show you a quick example of how this works. So I'm just going to go to this client PC here. And if I just run command prompt, and let's see if we can actually reach the virtual IP address, which we can. Fantastic. Now let's say, for example, that for whatever reason router X1 goes offline. So to demonstrate that, I'm just basically going to shut down the interface. And the one that this is connected to is gig01. So to do that, I just need to go into privilege board and then select the interface. So for the interface gig 01, and I'm just going to say shut down. And basically, in theory, if we didn't have HSRP set up, obviously the client still going to, it would go to that router, it would lose connection. But because of this virtual address, we should still be able to ping 10.25.25.1. It'll have a first timeout, which is when it's actually rediscovered it, and we get the successful replies back, which is fantastic. And then you'll also notice if I go into the router 2, we have a status change message here. So it identifies which protocol, in this case it's HSRP, and it's saying that it's changed from standby to active. So it's took priority and has managed to do that failover very effectively. So now what we can do is we can actually bring router 1 to be the active router again. And to do that, I just need to basically bring the interface back up. So if I just go back onto the interface 01 and just say no shutdown, what we'll do is we'll just keep pinging here. So we're still getting successful replies. It's still going to router 2 while router 1's still establishing the link back to the switch. But then we should see that router 1 goes to active. So if I actually just go to the command line here, as you can see, it's changed its status back from standby to active. So we know that that's actually working as well. So yeah, that's just a basic example there. We're going to get a bit more in depth, obviously, when we configure this again. But yeah, just kind of give you the rundown of how it works. So yeah, hope that helps. Okay, so we're just going to go over version 2 of HSRP. Like I mentioned before, there are two versions. And this one just has a few improvements. So, like I mentioned, it was created to improve version 1, and version 1 allowed 0 to 255 standby groups to be created, and version 2 now supports 0 to 4095. So you've got plenty there. I doubt you'd actually be utilizing that many on a single router. If you were, that'd be some crazy setup that you got there. But it's always good to know. And I think that actually makes it easier if you try to correlate them with VLANs. If you've got VLANs enabled on the network and you want to kind of make HSRP specific to a VLAN, then you can set the standby group to be the actual VLAN group, and that'll kind of keep track. So it's good for just administrating as well. V2 advertises and learns millisecond timer values, which you don't see in version 1. So definitely for networks that require high availability and high redundancy, that is a really good benefit to have there. So yeah, just another thing to take into consideration. And it also includes a 6-byte identifier field now in the packet. And this can be used to uniquely identify the sender of the message. So in version 1, you can't do that because it's using the virtual MAC address. So if you're trying to see where it's coming from, this packet, it'll just point back to that virtual MAC address. You won't know which router it actually went through. Now they've actually added a 6-byte identifier, which you can use. It's almost like a flag to tell you which way it's going. And also it uses the new multicast address and the new MAC address range, which you can see there. So yeah, just take them into account there. And next up are just some of the commands that are helpful just when you're setting up HSRP or if you need to do some troubleshooting. So you've obviously got the show standby brief, which will give you a brief description of how it's been set up. You can then actually debug errors in HSRP or events by using the debug command. I've just listed some there. And I can show you things like any error messages that have came up, or just the events in general. So the hello status is the hello being sent correctly, as well as actually the packets that are going through the HSRP packets. And I've just put a few more with show standby where you can include the priority, include if it's active, and another one where you can actually set the timers. So you've got the hello timer and the holding timer there, which you can set. And there will be a few more as well that I'm going to show in when we're actually configuring this. So we'll go a bit more in depth with these commands. So yeah, let's get started. So what we'll do is we're going to deploy this in Packet Tracer now, and show you how to deploy HSRP and how to maintain and troubleshoot it as well. So yeah. Hi everyone, and welcome to the final part of the video covering HSRP. So this is where we're actually going to configure HSRP in Packet Tracer. Just in this example, it's going to be quite a basic network setup, and I'll just cover how to set up version 1 primarily. So just in Packet Tracer, I'm just going to put 2 routers down here, just 2911 routers for example, and then we're just going to select a simple switch, and just for demonstration purposes, I'm just going to do one client PC there, and we're just going to connect them together. So what I'll do is I'll connect these to the switches through the gigabit switch, and I'll put both of these on gigabit or 1 just for simplicity reasons on the router end, and then we'll just connect the client device there as well. Perfect. So yeah, that's the basic setup there that we have. And what I'm going to do is I'm just going to assign the IP addresses to both these routers, just so they can communicate. And firstly, what we'll do is we'll just click no on the initial configuration prompt. Now we're into router 1. And sorry, what I should do actually is I'll change these, just make it a bit easier for us. Perfect. So yeah, first of all, we'll need to enable, and then if we go into configuration mode, and it'll be the will be the interface gig 01 that we want to be in, and we're just going to assign a static IP on both, 10.25.25.2 for the first one, because we're going to make the virtual IP address 10.25.25.1. So put the network mask on there as well, and duplex we're just going to set to auto. And then if we just do a quick standby here, so this is where we actually configure HSRP. But before I do that, what I'll do is I'll actually just bring that port up. So just do no shutdown, and that'll bring that port up there. And let's get into the HSRP settings. So firstly, we're just going to do standby IP. And this is where you actually set that virtual IP address, which we're going to set to 10.25.25.1. The next thing to do is just enable preempt, and simply do that by typing in the following: standby preempt. The next thing I'm going to do is set the priority for this router. Now remember what I was talking about with priority, so it's the one with the highest priority that's going to be the active router. And in this case, I'm just going to set that to 150 just for demonstration. And then the next thing we need to do is I'm going to actually assign 2 seconds the timers. So if I just do the timers, so this is for the hello timer and the hold timer. I'm just going to set them to 1 second and 3 seconds there. Perfect, so that's on there, and then we're just going to do standby version, and in this case I just want it to be version 1. So that's actually all that needs to be done on that end to get this working in its most basic configuration. There's a lot more to it. I'm going to post some links in the description of the video as well, just if you're needing any further help. There's some good documentation from Cisco. So what we'll do, we'll just exit out of there, exit out of there again. But as you can see, when we set this up, we already got a state change message here, saying that it's actually went from standby to active, so it's the active router. I remember that priority I set, which was 150. So we just need to make sure for the one that we want to be the standby, it has that lower priority. So we'll go to router 2, and we'll just basically do the same really. So go to enable, conf t, and then it's going to be interface gig 01. And for this one, we're going to set the IP address to 10.25.25.3, 255.255.255.0, duplex to auto, and then pretty much the same again. If you ever need any help, by the way, on any commands in Cisco iOS, type out the beginning of the command and then space and a question mark, and it'll give you the basically the options for there. So it's really helpful if you're ever getting a bit lost. But yeah, we're going to set the same gateway IP. So this is the virtual IP address. 2 seconds. Oh, that's my bad there. Typing too quick for my own good. So yeah, that's set there. And then the next thing, enable preempt. And then what we'll do, I'm going to set the priority. So 150 was for the other one. So in this case, I'm just going to set this to 140, for example. And the timers, I'm going to have them match. It is important to have them matching, just so it avoids any issues down the line. And we're just going to explicitly say it's version 1. And then what I want to do is bring this interface up. So that's coming up there now. And yep, perfect. So it's actually bringing HSRP up here. And what it should do is it should recognize that it's got the lower priority and go to standby. So I'm just going to wait for that. It's still initializing with the switch, which is why we haven't got that message yet. But if I just put this to the side, and we'll just pop that one there. There we go. Yeah, so as soon as it initialized with the switch, it recognized the active router on there because of those the hello message and the hold message. Perfect. So that's basically working there now. So what we're going to do is we're just going to test this on the client PC. So firstly, just for this example, because I haven't set up DHCP, I'm just going to give it a static address, and it's just going to be on .5. And for the default gateway, that's where I'm actually going to set that to the virtual IP address. So if I just pop this on 10.25.25.1, and we'll just do a quick IP config, make sure it's populated correctly, perfect. And now what we can do is we can actually test this just by pinging the virtual IP, and as you can see, we're getting a successful response there. And so that's basically it. So if we just now kind of simulate one of the interfaces going down here, so I'll just go back into router 1 and we'll do that real quick. So gig 01 do shutdown, and we should see perfect. That's all. That's pretty much instantly went from standby to active. And if we go back to the client PC, we'll get the first timeout while it actually updates the ARP table. And there you go, we've now got the successful pings there. So it's been able to do that crossover. And then, yeah, what we should see is if I bring this interface back online, like I said before, like I've shown before, it should go from active to standby now. Just waiting for it to do that initialization with the switch. And while we wait for that, I'm just going to see, because I should be able to show standby command. Yeah. So yeah, just even the show standby command can give you some useful information, especially if it's your first time being on the router. You can also do another useful command I like to use if it's my first time on the router and not really recognise it, is the show tech support command, and that'll basically give you the whole quite in-depth information about the current configuration. So you can come down here and you can see the interface, and you can already see, oh look, it's got HSRP set up, what IP address it's on, subnet, network mask. So yeah, really useful. And yeah, that's basically it. So I hope this video has been informative, and thank you for watching.